Okay, so welcome to our module. Today we will be explaining data science and machine learning, as you can see. So let's start. I'll start with a quick word about me. Just give me a second. Okay. So I'll start with a quick word about me. I'm Amanda Hashim, AI instructor at Zaka and a biomedical engineer. I'm interested mostly in machine learning and researches, as I've done previously research on EKG classification for sleep apnea detection. And here's my email and LinkedIn. Feel free to contact me if you need any help. So for today, we will start by introducing you to basic concepts of what is actually artificial intelligence, machine learning, data science, and all these terminologies you've probably heard. So we will meet some common real-life applications of AI, and we will also be exploring Python as a tool for data science and machine learning. And at last, we will finish this module with a hands-on example. So let's start with what is artificial intelligence. I know that the first idea of AI that was implemented through movies is these kind of evil robots trying to, I don't know, like replace humanity, take over them. But as exciting as it seems, this is not actually AI. Actually, this figure on the right is what represents AI, fair enough. It may not be as cool as the previous one, but by the end of this module, you'll be happy seeing this kind of result more than the evil robots. So in reality, artificial intelligence is simply algorithms. Algorithms are mathematical intelligent algorithms to which we can feed huge amounts of data, and they help us to extract some useful information and features in an automated manner. So they're able to extract patterns, learn from experience, to adjust on unseen or new data. We can say they really simulate the human intelligence, and this is why we actually call it artificial intelligence. Now let's briefly explore the types of AI we know of so far. We have three types: the narrow AI, the general AI, and the super intelligent AI. When we talk about the narrow AI, we talk about systems which are good at doing one specific task. It may be as good or better than a human would do it. So you can think like, for example, if you know the AlphaGo example, which is the algorithm that defeated the world champion in the broad game Go. So this algorithm is not able to perform a different task or a different game. This is why we call it narrow AI. But when we talk about general AI, it's a group of algorithms able to perform different tasks. So you can think like we humans are a great example of general AI, because we can learn different tasks and we can easily adapt even if we haven't been exposed to previously because of our experience. And the third type, which is the super intelligent AI, these are systems that are actually better than human at everything, and they do not need human assistance. So it exceeds the notion of intelligence that we are familiar with today. But at this time, we are still at the level of the narrow AI. So all of the applications today are able to perform one task only. Now, in the next slide, I will explain the main components of AI solutions. When we talk about the AI solutions, we talk about three main components or elements that constitute the AI model. We have the algorithm, the hardware, and the big data. We obviously have the algorithm, which is the program you will design to perform the specific task or the task you need to solve with your AI model. And you have the hardware, which is the platform on which your algorithm will run. And last, we have our input data that we pass to the algorithm. But why do you think we are interested in AI today mostly? To be honest, there are many reasons, but now I will talk about only a few of them. You can see that data is literally everywhere, and its amount is increasing with the rise of internet and big data, especially from social media, for example. You have so much content that is actively put out every day, from text, images, videos, audio, and all of the four combined. So we need for an automated way to process all this data and produce meaningful insights or discover patterns. Until now, is everything clear? Larissa, are you checking the chat?
Yes, there's no questions right now, so you can continue. But you can ask questions, guys, and interrupt. So feel free to ask or unmute. Ask questions.
Yes. Okay. Now I'll give you some applications of AI today. Can you guys give me some tips? Do you know some applications of AI today? Do you know some applications?
So you can write them in the chat or unmute.
Yes, feel free.
No one is answering. This means that
okay.
You're not here, or you didn't
Yes,
understand
does
the
it
question?
mean you're not with us?
Obviously, social media.
AI applications on social media, like what? Can you be more specific?
Well, Instagram, for example.
Actually, some of the tools on Instagram, like for example, when you have new suggestions, let's say, or ads, you sometimes feel like the ads are perfectly customized for you, as if they know what you're searching for. Is that what you mean?
Right, exactly, yes.
Yeah.
And the content itself, I think it's organized based on your user experience and stuff.
Exactly, based on the accounts you check, the pages you like, etc. Okay, cool.
So we have some answers in the chat: Alexa, Siri, Instagram and Facebook algorithm, Amazon.
Great. So now I'll give you some of the applications of the AI today. We have the self-driving cars. One of them, the self-driving car, is the one that was created by the Waymo company. It uses computer vision, deep learning, and it was built for fully autonomy with sensors that give 360-degree views and lasers that detect objects up to 300 meters away. The second one is a cool application called Style Transfer. It was made by Prisma company. It uses also computer vision, neural style transfer, convolution neural network. So it's the process as if you're reimagining one image in the style of other. You can think, for example, you can have like Leonardo da Vinci painting you a picture of your dog in just milliseconds. So it's actually a cool application. You guys said the Siri or Alexa, which is the virtual assistant. It's a great application, and I know you have all tried like Apple Siri, Google Home, or Alexa. It uses deep learning and voice recognition with natural language processing to provide assistance in everyday tasks. We have also Help the Blind See. It is a tool launched by Facebook that uses object recognition to generate descriptions of photos on Facebook and automatically generates a natural language text as caption for them to help them see what is actually the content of the image. We have many more applications, but we will proceed with the presentation. Okay, do you guys have any questions? Okay. I guess Larissa will be telling me if there are any questions, or feel free to unmute yourself. Okay. So you've probably heard me saying like deep learning, artificial intelligence, machine learning. So you've been hearing all these different terminologies that can be a bit confusing. Now it's time in this slide to define or specify exactly what do we mean by each one. As you can see here, first, data science is not artificial intelligence. What we can say it's the tool or method that work with data. It uses artificial intelligence to automate tasks, get results, and make predictions, but it's not AI. You can think of AI as the large bubble, including any algorithm that can mimic human behavior, as in recognizing patterns. Machine learning is a specific subset of the AI. Machine learning deals with statistical models to extract data patterns, and it improves with experience. And the last one, which is deep learning here, it's an even more specific subset where the algorithms actually mimic human brain. Now, machine learning is the creator of the model. It allows us to develop the algorithms to teach models that can predict new unknown data or perform human tasks. It takes training data as input and gives us a model in return. So it aims machine learning, the goal of machine learning is to develop an algorithm to solve or perform a specific task. This algorithm will be fed our training data, and after it learns, it will give us the model. Once the model has learned, it can be used for desired prediction of new unknown data or unseen data. Now, in the next slide, we will observe deeply this box of machine learning. What does it contain? So let's take a sneak peek into the machine learning box. So in this slide, you will deeply understand how this algorithm will take us from the training data we have collected to a model that you can use to take decisions. The most basic framework or pipeline for building a machine learning model consists of 4 major steps, as you can see. First, we have to collect our data. This data you will use for training. So after you collect your training data, you begin actually building your model, which can be represented as a mathematical function. You can think of a simple linear function like y equal wx plus b. So y being the slope and b being the y-intercept. So you can try your model with 0 or random parameters when it starts, and these parameters will be tuned during the training process. So as you can see, I get my training data after I collect it. I train my model, and each time I train it, I make prediction to evaluate and tune again the parameter of the model, and the process will go on until you find the perfect model that suits your task. But when we talk about machine learning, we have different types of machine learning. We have the supervised learning, we have the reinforcement learning, and we have the unsupervised learning. You can see when we talk about supervised learning, we'll talk about something called classification, like fraud detection, image classification, customer retention, etc. We have the regression. And in unsupervised learning, we have something called clustering or dimensionality reduction. And the last, we have the reinforcement learning. So in the next slides, we will explain each one aside. So let's start with our first machine learning approach. We have the supervised machine learning. In the supervised machine learning approach, the output labels are known. So we have to teach the model to produce the prediction that is closest to the output. So let's say you are trying to, you want to design an algorithm or a model able to differentiate between 2 classes. So you already know what is the correct answer or what the output should look like. You can solve it in 2 approaches. We have the classification and we have the regression. When we talk about classification, we are dealing with classes or category, which is categorical label. Like, for example, when we talk about the fraud detection, it's either spam or not spam email. If you want to put different animals in classes, it's either cat, dog, panda, etc. So the goal in classification is to draw, as you can see here, some kind of a boundary between different classes in your data set. But when we talk about regression, we are dealing with numerical labels, which is a continuous value, as if you're trying to predict the amount of customer purchases, age, price of house. So the goal here is to identify the pattern in your data through fitting data points on the graph, as you can see. This was the first approach or the first type of machine learning, which is the supervised learning. But when we talk about the unsupervised machine learning, actually the output labels are not known. So we don't have a specific desired output because simply we don't have a label. But what we desire here is to identify relationship in data set that can be used to group our data, for example. You can take an example, this picture. If you take this image and you want to group these random characters into similar clusters, here we say clusters and not classes, one way is the following. But if you work on something we call different similarity metric, we will end up with different clusters. So for example, let's say you have different images of animals and, or you can think, let's say we have different images of people and you want to perform clustering. So you want to group them into different groups based on a certain similarity measure. You can choose, for example, to group them by age, like for example, the kids aside, the adults aside, in a different cluster, or you can choose by gender, the male in a cluster, the female in another one. So it depends on the similarity measure you take. And the third type of machine learning is the reinforcement learning. The easiest example we take when we talk about the reinforcement learning is about games. So they have an agent. You can think the Pac-Man or Mario, for example. This agent will interact with an environment and perform actions. By performing these actions, the agent will receive a reward. This reward can be positive, indicating that the action the agent took was correct, or a penalty or a negative reward to tell or inform the agent that this was a bad decision. So the agent will learn through experience. If you take the Pac-Man example, you can think the Pac-Man will receive food, or the score will increase each time the action he takes is correct. But if he got killed by the ghost, he will lose the game, for example. So these were the three types of machine learning. Now let's move to data science lifecycle. In this slide, we will explain why actually there's an intersection between AI and data science, as we saw previously. So data goes through a lot of steps, as you can see here, before actually becoming useful and returning to the start where it gives more understanding. So data science, in fact, is a complete science involved with any work related to data, from collecting to processing, exploration, and much more. So we have actually several steps that typically need to be followed whenever we're working on a data science project. This is the main structure of data science lifecycle, but sure, you can shuffle things around, go back and forth between the steps. It depends on the project you're working on. Obviously, before anything, we need the data, right? So you need to collect information and data on the subject or problem you are working on. So let's say you're working on data about people. Maybe you need their age, their name, their education, their sex, for example, and many other characteristics as such. So it depends on the problem. But when you gather your data, you might end up with some mistakes in the data, for example, like some missing values, some redundant data, and many others. So even further than that, most times we have data coming from multiple sources, that we need to convert into one coherent format. You can think the example of data from Instagram and Facebook. If you want to combine them together, you will need to integrate them together. You can also discard unnecessary columns or features or characteristics that do not hold vital information. The next step is what we call exploratory data analysis. It's basically exploring our data. So we want to visually inspect it by plotting it, finding statistical relations, and find some sort of relationship in it. As an example, if someone is a smoker, he's more likely to have a higher medical bill over the year. So you are trying to relate or to plot your data so you can explore it. And just a quick reminder of the two very commonly used types of data visualization charts, which are the histogram and the scatter plot. Now you heard me, I mentioned the word feature a couple of times previously, and it's basically just an attribute or a characteristic that is shared by multiple units of the data. So we're looking for characteristics that can represent the data of our problem. This requires domain expertise. So if I'm looking at data for, let's take the example of a CT scan, I need to know which features of it will make a diagnosis for this CT scan or X-ray or anything. So relevant features for a certain disease can be like blood pressure, body temperature, but maybe like if I take the person height, I don't need it, so I can discard it simply. So the features are the characteristics that will help me to, or has a relation with the output. There's a fun fact, something machine learning experts like to mention a lot. It's how important data cleaning is to building and training algorithms. It takes up to 60% of the time just for data preparation and cleaning. So learning data science is a very important part even before jumping into machine learning and deep learning. Before I move to Python as a data science tool, is there any question?
So we don't have questions in the chat, but if anyone would like to go ahead
Unmute.
and unmute.
Yes, feel free.
Yeah. Maybe we can give a minute.
Yeah, sure.
Yeah, can you please explain, like, give an example of feature engineering? Because
Yes. Yeah, sure. When we talk about, do you want? I'll go back also to the slide. Okay. So when we talk about feature engineering, it is the step where you will start looking for some characteristics that are helpful or that will help you to better understand your problem. Let's say you have your problem is that you have to design an algorithm to predict how likely this person what's the probability of him having lung cancer. Maybe I care about his blood pressure. I care about his some of the pulmonary situation, but I don't care about his weight, for example. So in this step, you will extract the characteristics that are enclosed within the data that you care about, and discard all the features that you don't need, that won't affect your output. Is it clear?
Okay. So a bit. So basically, do I tell to the computer that these are the parameters that I want, or does it analyze it and come up with, these are the parameters that matter based on the data?
You can perform something we call feature mapping. So as if you are studying the importance of each feature or how it affects the output. And you can discard it from the beginning. Once you start studying your data or analyzing or visualizing maybe your data, that its relation with the output, you can simply discard it. Or when we pass to training the model, each input will be assigned to a specific weight, as if it's the importance of the feature. It will have a small importance if you want.
All right. Okay. Thank you.
Welcome. Any other questions? Okay. So now we will pass to the Python language as a data science tool. As you can see in this slide, these are the most popular programming languages. I assume you all have, you all know what is C and C++ or Java. These are programming languages. But as you can see, Python is one of the most popular programming languages. This is because it's easy to use, it's dynamic language, and it's widely used for machine learning and data science. When working on our hands-on exercise, in the next slide or the one next, we will focus on three main libraries. We have the NumPy, Pandas, and Matplotlib. These are libraries. We will explain them when we pass to our collab. Now, in this, in the hands-on exercise, we will be using Google Collaboratory. It's a free-to-use product by Google. It uses Google Cloud hardware to run your code, so there is no need to locally install any software, and it's easy to share with collaborators. So now it's time to move to our hands-on exercise, which is the material cost prediction. I will share with you guys the link of the collab, or Larissa, will you do it?
Yes, sure. Can you send it to me on Slack, please?
Yeah, just a minute. Okay.
So now you will have the hands-on, if you want, coding exercise, exactly. And you will be able to code along with Amanda on Google Colab. So we will send you the links so you can open the notebooks and get ready for the hands-on part.
This is the funniest part of the exercise.
Yes, and the most exciting part. So it's interactive and you can ask questions along the exercise.
Yes.
I'll send you the link right now. Okay. I sent it. So Amanda, you'll be sharing the how to open it. Yes. Okay.
Yeah, just 1 minute. Okay. Were you able to access the collab?
Okay, so Amanda, you sent me only the collab, not the drive link. So if you can click just on the white space, then give me the link. Yes. Okay. Now you can share. No, you're still now.
Yeah,
you clicked.
Okay.
Okay. So this is still selected. Let me try it.
Larissa, what did you say? Mathematic.
Send me the link and I'll check if it's good.
One minute.
Okay, so this is not the shareable link.
I changed it to anyone with the link. Can you check again?
Yes, sure. Let me check. Okay, now it's working. Let me share it with you. And let us know if you are able to open the drive link.
Yes, guys, if anyone is having trouble accessing the collab, please let me know. I'll share my screen meanwhile. This is the collab. You just have to right click, open with Google Collaboratory, and in case it doesn't show, just write collab. Just don't write Google Collab if you didn't use it previously. Write collab on connect more apps and you will get Google Collaboratory. Please press it. Were you guys able to open the exercise.
Okay, so 2 people worked with them. I think we're good.
Great.
3 people, yeah.
Okay, we can start, I guess.
Yes, you can start.
Okay, so as we said, Google Collaboratory is a free-to-use product. I assume, guys, you don't have any experience with it, so I'm gonna just take a fast overview. Here we have the name of the collab. This is the menu bar where you can open a file, edit, view, etc. In this collab, you can add. We have something we call text cells or markdown, in which you will include or you will write or add descriptions, and we have the code cells that you will run like this one. Okay. So you will start, and this one on the left, you have the search, we have the files. Here you have, for example, I have Drive, the sample data, I have this one. You can see how when we start our collab, you can see how the file that we upload, we will check it here if it's present or not. So I want you to start by connecting. Here, I guess you have, guys, connect, but before you have to create a copy on your Drive. So you can click File, save a copy in Drive. It will open a new tab with the same collab, okay? So again, File, save a copy on Drive. And this step, at this step, you will see the Connect button, okay? Are you guys with me?
Let us know in the chat or unmute if you're good or not.
Okay, again, File, save a copy in Drive. So this will create a local copy for you on your Drive so you can edit, okay? After you create a copy on your Drive, you can see it's copy of medical cost prediction, and you can connect. This will connect your Google to your Drive. Okay, so it will give you the amount of RAM or disk it occupies, okay? I'll start by explaining the collab, and please, if you have any questions or you were not able to connect, please let me know, okay? Okay. So our case study is the insurance medical cost prediction. So we will explore a data set of insurance data, and you will build a model to predict the cost of treatment for individuals based on their age, sex, body mass index, and other information. So the data set we will be using, it's actually a free-to-use data available on a certain website. We will just upload it in the next step. I will start by explaining to you guys what my data set contain as features. Remember, we talked about features. We said they are simply characteristics that has a certain relation, let's say, with the output we need to predict. So we have the age of the primary beneficiary of the insurance. We have its sex, being, for example, male or female. We have the body mass index, which will give us some information of the weight, the relation between the weight and the height. We will pass to explain it as the formula next when we start using it. We have the number of children covered by the health insurance or the dependent, whether the individual is smoker or not. We have the region or the residential area, and the charges, which is our target output. I'll start, guys, by asking you a question. Do you think the region will affect my output? So when I talk about feature engineering, do I really care where this individual is based to predict the insurance cost?
Yes, I think it does matter.
Why? Will it differ if someone is, like, say, in New York or California, or I don't know?
The medical costs will differ from one area to another. So
They are all in US. So do you
They're
think,
all in.
yeah. So do you think
No.
I care about? Okay, so maybe we will, in this exercise, you can see that we will try discarding this information. Okay, when we reach this part, I will re-explain it to you. Another question, guys. Do you think here our exercise is supervised learning or unsupervised learning? Take your time, look carefully to the dataset description. Feel free to unmute yourself or let us know in the chat.
Since different labels, isn't it supposed to be supervised?
Exactly. So our dataset contains actually the label, which is the charges, which are the charges or the our target output. So we have a certain training data in which I already know the correct answer, and this is the data I'll be using to train my model. So this approach is supervised learning. Okay. Okay. So the first step is before loading my data. As I told you guys, we will use some 3 famous libraries, which are NumPy, Pandas, and Matplotlib. We usually use NumPy for computation, like we use linear algebra to work on vectors or matrices. The Pandas provide high performance and easy to use data reading, manipulation, and analysis. So once we upload our data, we will use Panda to open the file we uploaded, our data file. Okay? And we have the Matplotlib. As the name says, we are going to use this for plotting or visualization. Maybe we will see how each feature is affecting the output or the relation between the features, etc. And we have another library with a site which is scikit-learn. It's a tool for data mining and machine learning models. So as you can see, I connected my Colab, and I will start by running the first cell. There is this arrow sign. Once I press it, it will start running. So in this one, I imported the specific libraries I'll be using. I imported NumPy, and I'll be using it as NP for short, PD for pandas, and PLT for matplotlib.pyplot. And from the scikit-learn, I imported the train test split, which is a function we will use to split our data. We will see it later. And I imported also the linear regression. As you can see, when I explained the supervised learning, I explained 2 approaches. Can you remind me what were these 2 approaches in supervised learning?
Plus and regression.
Classification and regression, right?
Yeah.
Okay. So why do you think this exercise is a regression exercise and not a classification one? What was the main difference between regression and classification?
In this case, there's no right or wrong or yes or no, or like 2 options only.
That's not actually the correct answer. We said that when we talk about linear regression, we are dealing with numerical data. So we don't have some classes. It's not categorical data because we are trying to predict the cost of the insurance. So the predicted output is a continuous value. So that's why it's a linear regression. Clear?
Yeah, all good.
Okay, great. So now we agreed it's a supervised learning approach and a regression exercise. So in the first cell, we are going to load our data. Actually, we have a repository on our GitHub. So you can simply start by cloning the repository. So this will give you access to all the files we will use, okay? You can refresh here. Okay, so now you can see I have a new folder called medical cost prediction. If you press the arrow, you can see that I have data. In the data, I have a file called insurance.csv. So this file actually is my data set. It's a CSV file, which means comma separated value. You can view it Let me see. Okay, you can view it here on the right. I have different customers, their age, their sex, their body mass index, if they have children or dependents, whether they're smoker or not, the region, and the charges they are assigned to. Is it clear until now? Okay, I assume this is clear. So after I cloned my repository, now I have my input data and I will start working on it. First, I will use from Panda. There is a specific function that allows me to read my CSV file. This function, do you know, guys, what it is?
Read underscore CSV?
Yes, exactly. What parameters should I pass to the read CSV file, to the read CSV function?
Yeah, you have to pass the CSV file. That is the path underscore to underscore data.
Yes, the path file. So guys, if you don't have the path file, 1 minute. Okay, if you don't have the path file, you can simply right click on the insurance.csv and copy the path, and you will obtain this one, content/medical cost prediction data insurance. You can run it. And when it comes to reading your file, as you said previously, we simply use the panda dot, 1 minute. Okay, you can simply use the panda for short PD dot read underscore CSV path to data. And to display, we are going to display the first 10 rows. Do you know, guys, which function am I going to be used?
Head is the function.
Head function. So the head function takes as parameter the number of rows, or we call instances, you want to visualize. It's by default 5. I'm going to choose 10. Okay. Okay. So as you can see, I will repeat. I copied my the path to my data, which is on my drive. It's my CSV file. I just right click, copy the path, and paste it here. So I can pass this parameter to the read CSV function, and I displayed the first 10 rows. Okay. Here, as you can see, I have different different persons or different instances. They have indexes from 0 to 9, which gives me 10. We have the different features, which are the age, sex, BMI, etc. Now it's time to explore our data, or exploratory data analysis. So let's dig deeper and understand our data. In the first code cell, we want to get the number of rows and columns. Do you know, guys, which function am I going to be used? What is the function that gives me the number of rows and columns? Okay, so it's the shape function, okay? The shape function gives me actually two output. The first output, which is of index 0, it's the number of rows of my data. And the column number 1, or the second output of index 1, is actually the number of columns, okay? So I'm gonna print the number of rows and columns. As you can see, I have 1,338 rows, which means instances, and 7 columns, okay? Is it clear until now?
Yes, so we had one answer in the chat. It was correct.
Okay, great. Now let's move to the second part. There are also some functions that you can use to get some information about your data, like data.info. The function info will check the data type, if there are any missing values, the memory your data set is using, and the number of rows and columns. So as you can see here, I have 1,338 entries from 0 to 1,337, which is the number of instances. I have 7 columns. You can count it from age to the charges, which was previously mentioned in the data description. None null, which means no missing values. we have the type of my data. It's either integer for numbers like age, object for sex, which because it's categorical data, we said it's either male or female, and etc. Okay, we have also the memory usage. Okay, so this function gave me only some information about my data. We can also use the function describe to check the mean, the standard deviation, the maximum and minimum of each numerical feature. So as you can see, I have only the age, the body mass index, children, and charges. So the sex is not counted, the region is not included because they are not simply numerical features, okay? So these are the count, the mean, etc. As you can see, for example, the body mass index is missing some values, okay? In case you noticed, okay. So now I will move to check or take a look at the distribution of charges. In this section will help us to know how much patients spend on treatment on average. So I'm going to plot the charges using the PLT on a histogram. So I will use the plot function here. I'm going to plot only. Here, as you can see, data, charges. So I want to plot the charge column, and the kind of my plotting is histogram. I want to give my plotting distribution of charges title. The X label is charges, and the Y label is the frequency, and I'm going to show the image. So as you can see, here I have the frequency of the charges. So I have most of the charges are from, let's say, around 10,000, okay? So I'm only trying to understand or visualize my data for better understanding, okay? So this step actually is useful to study the correlation between some features and the output. This is what I meant when I said feature engineering. Maybe there is no relation between the output and the country, or we said it's the region. But it may be, maybe we have a correlation between whether the patient is smoker or not. Maybe he is most likely to have high bill if he is a smoker. So in this part, we will see how many smokers versus non-smokers we have. So first, we have to select the smokers and select the non-smokers, and then we will print their numbers, okay? So I will choose, for example, here, when I want to select the smokers, I will say, I will loop over my data, and each time, if the current smoker of my data set is yes, which means this instance or this person is a smoker, please add it to a new array called smoker. Is it clear? Guys, is it clear how we are selecting the smokers?
Yes, we have 2 yeses.
Okay, so but a quick reminder here, I don't care if he is, I'm not counting the number of smokers, but I'm copying the complete row, the complete instance with the 7 columns, okay? If he's a smoker, I copy the complete instance, the complete row, and I put it in a new array called smokers. And the same one goes to select the non-smokers, but this time I have to select the instance if the data.smoker is no. And last, I will get the shape of the smokers array. I will select the first one because it gives me the number of rows. Because the number of column, I don't care about it. It's only the features, which is 7. And the first number of the shape of non-smokers to see how many smokers and non-smokers do I have. Let me check. Just give me a second. Smokers shape. Okay.
Remove the dot George mentioned.
Yellow 1 minute.
Yes.
Oh, I removed the wrong one, I guess.
And the colon as well, so it's just dot format. I meant apostrophe, sorry. The apostrophe and the dot. Yes.
I guess still it's not working. Just give me a minute, guys. No, maybe we need it. Wait a minute. That's weird. Just give me a second, guys. Okay. Okay, I'm gonna reshare my screen now. I fixed it. Okay. So, as you can see, there are 274 smokers and 1,064 non-smokers. As I said, guys, I took the first output of the shape of smokers and the non-smoker, and I printed separately. Is it clear until now? Larissa, if you want, I cannot access the... Do you think I need to copy the code in the chat or it's clear now?
I can copy the code in the chat if anyone is
if anyone needs, yes.
Are you facing any errors? You can also mention this.
Yes. Okay. In the next step, I'm gonna plot the charges for both smokers and non-smokers. Okay, so I'm gonna plot the histogram of charges for smokers and non-smoker. So as you can see here, I choose my figure size and I add two subplots here and here. In the first one, okay, so in the first one, I'm gonna plot the smoker's charges. So it's only the column of the charges from this smoker array we previously defined. And the next one goes the same for the non-smoker. So I will just plot the histogram of the non-smokers. Okay, so as you can see, can you guys try to analyze these two graphs? In the first one, we have distribution of charges for smokers, and on the right, we have the distribution of charges for non-smokers. What do you notice? Remember, we are plotting the charges for smokers and non-smokers. Is there any correlation between the charge and whether being a smoker or not? Or
yes, so smokers have some bills that are around 40,000, and those.
Yes.
And for non-smokers, it doesn't even reach that. It's just 35,000 is the maximum.
Yes, exactly. So do you think we can discard this feature, whether being a smoker or not, or it's important?
No, it's definitely important.
Yes, it's definitely important. So at this step, we can see that the smoker, whether being a smoker or not, is a very important feature, so we cannot simply discard it. Okay? So smoking patients spend more on their treatment. Now we will study here in the next section the correlation between the age and the cost of the treatment. So we are going to repeat the same steps, okay? So I'm going to start by plotting the histogram of the age of my data. So here I will simply write histogram. I want to plot a histogram of the age column in my data. So my patients range from like 20s to 60s. This is the age distribution of my data. And in the next one, I want to draw a scatter plot. Remember, this was the second type of the plots we will be using. Scatter plot to see if there is any correlation between age and charges. And I'm gonna plot it in two different colors just to differentiate between them. So I will plot the age versus charges in color blue, okay? Okay, so as you can see in this image, let's try to analyze it together. Yalla guys, give it a try. I know that the age range from 20 to mid-60s, let's say. But how do you think the age is affecting the charges? Guys, I'm waiting for you. The cost of treatment for different ages.
So it's increasing with age.
Are increasing?
Yeah, obviously we can say there is a correlation between age and cost. And as your friend mentioned, the cost or the charge increases with the age. You can see that we have a certain part of our data is like in 20s, and even if they are in 20s, the charges can reach or almost 40,000, and in 60s. So this feature cannot actually be discarded. But let's check if smoking also affects this curve. So I want you to try to show a scatter plot with the correlation between age and cost of treatment while showing smokers in red and non-smokers in blue. So I want a scatter plot where you will add whether being smoker with age and the charge to study the correlation between smokers, non-smokers, and the charges with age. Okay? Can you give it a try? I'm gonna help you with the first one only. Give you a hint. I'm gonna start by adding here. I want to do a scatter plot for the smoker's age. So in this part, it's easier to plot to use the array we already defined. Remember, we defined two arrays. The first one is for smokers and the second one is for non-smokers. So simply plot the age and the charges from the smoker array in color red, let's say, and plot the second one in blue. So just give it a try for the non-smokers. So here you will have to add the scatter plot for the non-smokers, and then this is the title of your plot, the cost of treatment for different ages, where you will plot the age versus charge, or charges versus age, but with different smokers and non-smokers. Is it hard?
It worked.
It worked great. Okay, so simply I write the same as the previous one, but instead of choosing smokers, I will use the non-smokers in blue color. So as you can see, it's the same as the previous one, but it's coded in color. The red one goes for the smokers, and the blue one goes for the non-smoker. What do you notice, guys?
Non-smokers have lower charges.
Exactly. Non-smokers, now we know that the age is affecting the charges, and also whether being smoker or non-smoker, it's also affecting the charges, and we know the actual relation. As you said, smokers are more likely to have high bills, or the charge will increase whether the customer will be a smoker or not. Now we pass to the feature of the body mass index. Guys, can I proceed, or is there any question? feel free to unmute yourself, okay? Or let me know in the chat if everything is clear. Okay, I will proceed, and please, if anyone is having a problem, please let me know. In this step, we will study the correlation between the body mass index and the charge. But first, I will tell you how to calculate the body mass index. So it's actually the weight divided by the squared height. In this chart, as you can see, we have the one in this color. It depends on the height and their weight, being classified as underweight, which is having a value, let's say, less than 18 or between 18 and 24. It is classified as underweight. From 25 to 29, healthy. Overweight from 30 to 30. Overweight until 29. 30 to 39 being obese, and 40 to 42 extremely obese. So first let's take a look on the body mass index distribution in our data set. So then we will look at the correlation between the body mass index and the charges. So as we did before, we are just going to plot the BMI column as histogram. So here I'm just going to add the kind of my plot just to visualize my data. Okay, so as you can see, my body mass index ranges between, let's say, 16 to above 50. So it gives me, as you can see, my data set is diverse. I can have customers underweight, healthy, overweight, obese, and extremely obese. Okay, so this is a good data set actually, okay, because it gives me all the possibilities. Now, according to the chart, the above chart that we obtained in blue, obesity starts at the one we explained here. We can see that obese starts around 30, okay? And if you take a look at my chart, I can see that the people or the customers having being obese are having are frequent, and we have a good amount of customers being obese. Okay, now it's time to see how the BMI is affecting our treatment or our cost. So we will start by selecting different different customers. I'll be using the obese, the overweight. Okay, the obese, overweight, healthy, and underweight. Remember, if he's being obese, I should choose the body mass index that is greater than or equal to 30. Okay? So here, I will loop over my data. If my body mass index is greater than or equal to 30, then this person should be classified as being obese. Now, if I take the overweight, we said the overweight let me go back to the chart. Yes, obese, it's above 30. Okay, we have the overweight between 25 and 29, or less than 30, we can say. So here, I will add this one. So if the BMI is greater than or equal to 25 but less than 30, select this instance, the complete row, and put it in the overweight. I will choose the underweight having BMI less than 18. We still have also the healthy one. And the healthy, depending on the previous chart, has a body mass index between 18 and 25. So again, if the BMI is less than 18, then this person is underweight. If its body mass index is between 18 and 25, he is healthy. If he's between 25 and 30, overweight. And if it's above 30, it's obese. We can also add, if you want, extremely obese. Then I'll take the shape of each instance and take the first one as the number of individuals. Okay, so in our data set, we have 705 persons obese person. We have 385 overweight and 230 healthy individuals. Okay, I guess we don't have some underweights. Okay, so let's continue. Okay, now to compare, let's plot here the distribution of charges for all the three groups since we don't have underweight in one plot, while showing obese data in red, for example, overweight in yellow, and healthy data in green. So I'm gonna plot the three cases we have. We have the obese, the charges of the obese in red. So I will use the instance, the array we already defined. I will plot the charges of the obese array in red. We have the charges of the overweight in yellow, and we have the healthy in green. Let me know, guys, if it worked. Okay. What do you notice, guys? What's the relation between being healthy or not? How is it affecting the charge?
Charges increase for unhealthy people, for obese, but the ones in red.
True, because that's exactly. So the patients with body mass index above 30, which when we talk about the obese people or the overweight, they spend more on their treatment, so they have higher charges. So now it's time to process our data. It's what we say, garbage in, garbage out. Remember when we explained, I said that most of the time is actually spent on cleaning or processing your data. So data should be processed and cleaned to get rid of noise data, some missing values, remove, like for example, if we are dealing with some missing data, you can remove the whole instance, for example. Actually, this one is how you write your markdown, and this is how it will be displayed, okay, in case, guys, you need it. Okay, so you can remove the whole instance, or you can infer, which means the date of birth and age. You can remove one, or you can fill it with the mean or median or even zero. If you fill it with the mean, it won't affect the result, so you'll be dealing with the missing data without any issue. If there are some unused columns, like when we talked about the country or residence, maybe this feature is not important, so we can remove it. You can convert categorical data into numerical, like when we calculated the mean and standard deviation and some statistical values for the numerical columns. For the categorical data, we didn't do anything, so we should replace it with some values. And last, we have to normalize or standardize ranges. 1 minute. Okay. We have to normalize or standardize our data for all features, which means we can make all the values between 0 and 1, or else the algorithm will assume that the features having higher values are more important. And let's say we take the age regarding, or for example, the age versus the body mass index. Maybe the algorithm will consider the age, if he's 60, is more important than the body mass index, which is 18. So we need to normalize our data between 0 and 1. So we will start by removing any missing data. First, I will print how many missing values in each column I have. As you can see, I told you before, we have 3 missing values in the BMI column. Do you remember? When we printed the shape or the some characteristics of when we wanted to visualize some information about our data set. We had 3 missing values of the BMI. Do you remember, guys? Guys, are you still with me?
So
Yes.
George and Lala mentioned yes.
Okay, great. Okay, so the first way we can deal with some missing values is that simply we can drop it. Drop it with, we can use the data.drop NA. So we drop the not available data if you want, or the missing values. And again, I'm gonna count how many missing values do I have. So as you can see now, I don't have any missing values. So if I print some information about my data, they all have the same number of entries, which is 1,335 instead of 1,338, okay? And the second step is to remove the unused column. We said previously we can remove the region column since we don't really care about, because it doesn't affect the output or the cost. Okay, so I'm gonna drop the region feature, drop region access 1 in place true, and I will print the first 5 rows. Remember, head by default takes 5, so it prints me the first 5 instances. As you can see, I still have the age, sex, BMI, whether they have children or not, and whether he's a smoker or not, the charges, but I don't have anymore the region feature. Okay. Now, the next step is to convert categorical columns to numerical. Here we have 2 columns that are categorical type. We have the sex column, and we have the whether he's a smoker or not. So we have to compare male or female to 0 or 1, replace it with the 0 and 1, and smoker or non-smoker also with 0 and 1. So to do this, we have to define a dictionary. In this dictionary, we will name this dictionary gender for the first column and smokers for the second one. As if we are saying, I have a dictionary, I'm defining a dictionary where the male will be assigned the value 0 and the female will be assigned the value of 1. So after I define my dictionary, it's time to replace my sex column with either 0 or 1, for 0 for the male and 1 for the female. So remember, the sex column of my data, I'm gonna apply on it the gender dictionary I did, and I will print the first 5 rows to see the result. Okay, so as you can see, now the sex is no more male or female, just as the previous one. I had the first one female and the next 4 individuals as male. So now I have it 1 for the female and 0 for the male. Is it clear until now? Remember, we are dealing with categorical data at this step. Okay? Clear, guys?
Yes.
Okay, great.
All good.
So, great. So I'm gonna do the same thing for the smoker columns. Also, I'm gonna give 0 if he is not a smoker. So 0 for no and 1 for yes. And I'm going to apply this dictionary or this dictionary to the smoker column of my data, and again print the result. So now, if he's a smoker, yes, now it's replaced by 1, and for the next individuals, we have 0 because they are not smoker, they are non-smoker. Okay. Now the next step is to normalize our data. Remember, we have to scale our data, or all the columns in my data set to values between 0, and 1. So, sorry. This can simply be done by dividing each column by its maximum. So I'm going to get the maximum of my data. I'm going to get the maximum of my data. Here I have the maximum of the age, the maximum of the sex, the maximum of the body mass index, children, smoker, and the charges. And in the next step, I'm going to divide each column by its maximum. So I'm going to divide my data by the data max I already obtained, okay? Divide my data by the data max I already calculated in the previous code cell. And I'm going to print a description on my data set. As you can see, all the values, the mean, the standard deviation, they have. The minimum now is 0. Like for example, 28, 3, 0.01, and the maximum is 1 for all the features, okay, for all the columns, let's say. Okay, so now I normalized my data, so my algorithm won't assume that one feature is more important than another since it has a greater value. At this step, we finished or we are done with data processing, okay? So now it's time to start training our algorithm and test it. So can we pass to this step, or guys, do you have any question? Is it clear?
We don't have any question in the chat.
Okay, great. So before training, we need to split our data set into a training set and a testing set. In this step, we will use the scikit-learn library, and we will use 80% of our data set as training, and 20% as testing. So I'm going to use the train underscore test underscore split function here. I'm going to tell you what I did in the previous step. Remember, in my data set, I used only the last column as the output, which is my y. This is my target variable or my target value. And all the values of the column except the last one, which is -1, they are, I consider them as the training data or as the input features. So when I want to split my data, I will pass it the x and y, which is the input features and the target output y. The test size is 20% of my data, which means 0.2, and the remaining 80% goes for the training set. And we have a random state equal 42. Do you know, guys, what does this mean? Random state equal 42?
Not really.
Okay, so when I give this parameter to the train underscore test split function, it means that the split I will obtain is replicable. So it means if this instance is taken this time for training, the next time I will obtain the same split. Okay, so if I run the code several times, each time the same answer, the same result I will obtain. And I print the shape. Okay, this function will return me the xTrain, xTest with the corresponding output for the train and the test. I'm gonna print the shape of my data. So as you can see, I have 1068 instances for the training and 267 for the testing, with only one output. Okay, this is the y train, and this is the y test. And the last part of this exercise is to model our problem, or to create the linear regression model. So first we have to find our regression model. We will simply use it by, if you remember, we imported the linear regression model from the scikit-learn library. So I will create a model equals simply linear regression. Now it's an empty model, and then I will use the xTrain and yTrain set to fit my model or to train my model on these instances. So I call model.fit as if I'm asking the model I created to train yourself on the X train, and these are the output labels, which are the correct answers. Okay, so the model will use this data to train or to tune the parameters, and then I can evaluate my model if he is well trained or not. Is it clear until now? We simply created the model, the linear regression model. Simply we call this function and we obtain a linear regression model, okay? And when we train or fit our model on our data, it will tune the needed parameter. Let me know if you have any questions, okay? So now to evaluate my model, I will simply use the score function. So the model I created and which is trained by now, I will pass this model the X test and Y test, and it will give me back the scores of this evaluation. So as you can see here, my model score is 0.84, etc. So it means that I have an accuracy around 80%, that my model guessed around 80% of the instances that were in the test size or in the test set. Are you guys with me, or you have any problem? Let me know, please. Okay. Meanwhile, I will continue. I will use, for example, some of the instances in my model to predict. So I will choose the test, one of the instances of the test set, the one of index 4. This is my sample. I will only reshape it because if I don't reshape, it will give me error because the predict function actually needs a two-dimensional array. So I will add here the reshape function just to reshape my sample into 2D, and then I will use here the predict function and pass it the sample to predict the score. Okay, so for example, it gave me that the predicted value or the predicted charge for this sample is 0.14. Remember that even the values that are predicted by the model, they are normalized, okay? So this is why the value I obtained is between 0 and 1. Is it clear? You can use any sample you want, okay? But remember, it should be cleaned and processed. That's why I used one of the test set.
We have one clear answer. Yes.
Okay. Let me know if you have any question. I'm gonna pass to the last part. Remember when you guys asked me about the feature engineering part, I told you that there is actually an option where you can plot the feature importance, or what we call weight, if you remember W from the slides. So in this one, I can simply visualize how each feature is affecting my charges. So I'm drawing, or I'm plotting the coefficient or the weights of each one. You can see that the sex is not actually affecting the output, which is predicted, but mostly whether being smoker or not is the feature having the higher effect on the cost, okay? There is certainly a correlation between the BMI, the age, and a little one, a small correlation between having dependents or children, but mostly the smoker. You can do it, for example, from the beginning if you want to discard some features. It also worked, but remember your data should be numerical, okay? Is it clear, guys? You want me to repeat anything?
So anyone has any questions, even if it's regarding maybe your results or your prototype, if you're doing anything, you can ask now. Thank you so much, Amanda.
Welcome. I hope it was clear and you enjoyed it, guys.
So please let us know. You can unmute and ask questions if you have any questions. You can also give feedback if you want regarding the session.
Yeah. If there is anything that wasn't clear or it needs, I don't know, some explanation or more time.
So we have Ola. Yes, thank you so much. Thank you from George. Okay. So do you have specific question regarding your prototype? You can ask them now if you want. Otherwise, we're done.
Yes.
So please let us know if you have questions. I'll wait a minute and then we're done. Thank you so much, everyone, for joining. And I hope tomorrow we will see you in the how to pitch session in the morning, and then hopefully we will see what you've been working on. Okay, so we don't have any question. So
okay, great.
Thank you so much, Amanda. Have
Welcome.
a great
Thank
day.
you, guys.
And for the
Thank
teams,
you.
if you have any question, you know where to reach us. You have the Teams channel. Feel free to ask any question and we're here to support. Good luck for tomorrow's recorded pitch, and I will see you in the how to pitch session tomorrow at 9. Bye. Have a great day.
Have a great day. Goodbye.
Bye.
Bye.